Let's look at a couple more examples where the substitution is a little bit fancier, a little bit trickier. The first one will be number 53, which is the antiderivative of x times the square root of x plus 6 dx. Since we see the x plus 6 inside the other function, the square root, that gives us the idea of setting u equal to x plus 6. And that's indeed the correct way to start this. For the differential du, the derivative of x plus 6 is 1, so I end up with 1 dx. So du is simply equal to dx in this substitution. So now let's substitute. The dx becomes du. The square root of x plus 6 is going to become the square root of u. But we still have to do something with this x. Everything which is in the original integral has to be represented in the new integral. So here's the trick. Using this substitution, if u is the same as x plus 6, then that means that x is the same as u minus 6. I can subtract 6 from both sides of this equation to get x equals u minus 6. So here where I have an x, I put u minus 6 instead. So remember, whenever you do a substitution, everything in the original problem has got to be represented in the new one. And now how can we integrate u minus 6 times the square root of u? Well, we've seen problems like this before. We'll rewrite the square root of u as u to the 1/2 power, and then we'll distribute that across this binomial. Remembering that u is the same as u to the 1st power, when I multiply u to the 1st times u to the 1/2, that gives me u to the 1/2, which is 3/2, minus 6 times u to the 1/2. And now I can integrate this term by term using the power rule. To get the antiderivative of u to the 3/2, I add 1 to the exponent, which gives me 5/2, and then I multiply by the reciprocal, 2/5, minus 6 times, adding 1 to the exponent, u to the 3/2, times the reciprocal 2/3 in front. Or simplifying just a little bit, this is the same as 2/5 u to the 5/2 minus 12/3 is the same as 4 u to the 3/2 plus c. And then we can replace the u with x plus 6. So we have 2/5 times x plus 6 to the 5/2 minus 4 times x plus 6 to the 3/2 plus c. And on a test, this is where I'd like you to leave the answer. But you may notice occasionally, if you check your answer in the back, they may decide to factor out the greatest common factor of x plus 6 to the 3/2, and then combine the rest algebraically, kind of like we did when we were simplifying derivatives. Let's do one more example of this type, since it can be a little tricky, as I said. This will be number 55, which is the antiderivative of x squared times the square root of 1 minus x. We'll start with our u substitution. U equals 1 minus x. And then calculating the differential, du is negative 1 dx. The derivative of 1 minus x is negative 1. So kind of like that problem we did a few minutes ago in the previous video, I need a negative 1 dx. So I can multiply by a negative 1, and then multiply by another negative 1 on the outside. I haven't changed the integral because negative 1 times negative 1 is 1. Now let's switch everything over to u's. Negative 1 dx becomes du. The square root of 1 minus x becomes the square root of u. But in front, I need to put an expression to represent the x squared. Looking over here, if u is equal to 1 minus x, then that means that u plus x is 1 if I add x to both sides. And then subtracting u from both sides, I get that x is 1 minus u. So here where I have an x squared, I can replace that with 1 minus u squared. So once again, everything's accounted for. The differential negative 1 dx became du. The square root of 1 minus x became square root of u, and x squared became 1 minus u squared. And I also brought down the negative 1 in front. Now, just like in problem number 53, we want to expand this out and then eventually distribute the square root in. So first of all, let's take 1 minus u and square it. That's 1 minus 2u plus u squared. And the square root of u I can write as u to the 1/2 power. And then I'll distribute this in so that I have negative the integral of u to the half minus 2 u to the first times u to the half is u to the 3/2 plus u squared times u to the half. 2 plus 1/2 is 5/2. So most of what I've done here is algebra. I haven't taken my antiderivative yet. So now I need to apply the power rule 3 different times. Once again, I'm bringing down this minus in the front. Term by term, I'm going to add 1 to the exponent and then multiply by the reciprocal of the new exponent. So 1/2 plus 1 is 3/2. The reciprocal of that is 2/3 minus 2 times, adding 1 to the exponent, 3/2 plus 1 is 5/2, and the reciprocal is 2/5, plus 5/2 plus 1 is 7/2, and the reciprocal of that is 2/7. And now I'll add my plus c. And we're almost there. I'll just simplify the arithmetic a little bit and maybe go ahead and distribute this minus sign. So I have negative 2/3 u to the 3/2 plus 4/5 u to the 5/2 minus 2/7 u to the 7/2 plus c. And then I can substitute in that u is the same as 1 minus x. So I have negative 2/3 times 1 minus x to the 3/2 plus 4/5 times 1 minus x to the 5/2 minus 2/7 times 1 minus x to the 7/2 plus c.